in this section what we're going to do is we're going to mix up and see if we can identify the factoring technique that we need to use on a particular expression. Let's begin. We're going to factor 9x to the fourth y squared minus 9y squared. Now immediately, since you see two terms, you might think, well, that could be the difference of perfect squares, which is you're correct. But the key in this section, as is in all factoring, is to first of all look for the greatest common factor, or the GCF. So let's check. Do we have a greatest common factor in this first problem? 9x to the fourth y squared minus 9y squared. Well, I think this 9 is pretty obvious as a GCF, so we'll write that down. Notice both terms also contain a y to the second power, so that's also part of my GCF. So to avoid mistakes, to make your factoring more simple, keep in mind that greatest common factor. So there it is, 9y to the second. To get our first term back, we need an x to the fourth. To get our second term back, we just need to multiply by -1. So there we have it. Now, in this particular section, we're going to have to keep looking at what we factored to make sure that we are in completely factored form. In this case, let's look inside. I've got an x to the fourth minus 1. Two terms, a minus sign, perfect square, perfect square. Don't I have the difference of perfect squares? I certainly do. So this 9y squared stays out front, and I'm going to factor into x squared plus 1 times x squared minus 1. Remember, x to the fourth is a perfect square. It's x squared times itself. Now, don't get too anxious and go to the next problem. Always check to make sure that you're completely factored. Check our last term here. X squared minus 1. Two terms. I got the minus sign. I got a perfect square, another perfect square. It's all set up again for the difference of perfect squares. So I rewrite my first two terms. Notice nothing changed there, but I see that I have the difference of perfect squares, and it's going to factor into x plus 1 times x minus 1. Now, check down at the end. Does that factor one more time? You're right, it doesn't, because even though we have a minus sign, this x is not a perfect square. The 1 is, but the x is not, so we cannot factor one more time using the difference of perfect squares, because in that case we must have two perfect squares. So here we go. Oh, we got a long one there. This 9x to the fourth y squared minus 9y squared factors into, and this is called the complete factorization of this original binomial, is 9y squared times x squared plus 1 times x plus 1 times x minus 1. Now let me give you a little hint on what I normally do to hopefully make this easier for yourself. Whenever I factor the difference of perfect squares, I always write the plus first, the plus term or the plus binomial first, and the minus binomial second, just in case, as it did here, this one factors again, and then I can line up my terms and then split whatever's at the end into its new factorization. I just like to do that just to keep it a little easier. You don't have to do that, but that's just a little hint. Let's look at our second trinomial. 12x minus 9 minus 4x squared. For one thing, this trinomial is presented in rather an odd order. Would you agree? These terms are not presented in descending order. Remember, descending order is where the variable, the powers, descend from highest to lowest. In this case, my highest power is here at the end. So I'm going to rearrange the terms and write this trinomial in descending order. So this becomes minus 4x squared plus 12x, and then I've got a minus 9 there. So basically then I'm back to factoring a regular old trinomial. But there is another little problem with this particular one. I personally don't like to factor trinomials when the leading coefficient is a negative number. So what I'm going to do here to alleviate that problem is to factor out a -1, since I don't have a greatest common factor, I can see I can take out that negative 1 there, or just a negative sign, 4x squared. Now notice, because we're factoring out a negative, it's going to change all the signs of the other terms. That makes that a negative 12x, and makes this a positive 9. Check the signs. Negative, positive, negative were correct. Now, let's check to see if we have a special case of factoring here. Remember, in order to be a special case of a trinomial being factored, we have to check, is our first term a perfect square? It happens to be, isn't it? 4x squared is 2x times itself. Is this last term a perfect square? Yes, it is. 9 is 3 times itself. To check for the middle term, we multiply these two together, 2x times 3, 6x, and then double it. 12x certainly works, doesn't it? So this is a special case of factoring. In fact, leaving the minus sign and setting ourselves up here, we put the 2x and the 3. Now, the only thing we have to worry about a little bit here is the sign. We want a positive product, but we want a negative sum. So in order to get that, we must make this a negative sign, because a negative 3 times a negative 3 will give us that positive 9. And then we're going to get a negative 6x if we wrote it all out, and a negative 6 out in the middle to get a negative 12x in the center. So that does work. If you're uncomfortable with that, then go ahead and write these out as 2x minus 3 times 2x minus 3. Go ahead and FOIL, and you'll check to see that we get exactly what we started with there. Now, one other thing I want to caution you about. You may be feeling a little bit overwhelmed, saying there are way too many rules to remember. I'll never do it all. If you did not recognize this particular special case of factoring, and you proceeded by factoring by grouping, which is playing that product sum game that we did when we factored trinomials, you would still end up with the same solution. It would just be a little bit longer, but you'll still get there. So don't feel overwhelmed. If you cannot remember every special case, you can still use the basic ones, and they'll still get you to the correct factorization. Let's take a look at our next special factoring problem. We're going to factor here 5x cubed minus 15x squared y plus 10x squared minus 30xy. Immediately, you may be feeling a little bit overwhelmed at the complex problem you're looking at here. But we're going to take it step by step. Remember, the key to factoring. Let's first look for the GCF. 5, 15, 10, and 30. The numerical GCF would be 5. So we'll take that out. Let's check to see if they have a variable in common. X cubed, x squared, and x. So they at least have an x in common, so we'll factor that out. Now, let's go ahead and complete the factorization here. We've got 5x times x squared gives me 5x cubed, minus, I need a 15, so I'm going to multiply by 3x to give me the x squared, and I need the y, plus 5 times 2 will give me 10, and I need x times x to give me the x squared. Finally, I have 5x. I need to get my 30. In fact, that's negative 30, so I'm going to make that negative 6. I've got the x's taken care of. I'm going to put a y right there. At this point, you may still not be feeling too great, but count 1, 2, 3, 4 terms. The key, if you can recognize when you have 4 terms, factor by grouping. Group the first 2 together and the second 2 terms together. Now what I'm going to do, because I'm going to have lots of parentheses here, is I'm going to use a symbol for parentheses. I'm going to use brackets. So I'm going to put a bracket here, and then the GCF in the first 2, x, parentheses, x minus 3y, plus the second 2, GCF, 2, parentheses, x minus 3y, and parentheses, and I'm going to change this parenthesis, which matches the other one there on the far left, to a bracket, so it's easier to see that these match up and then these two as well. Well, are you feeling a little bit better at this point? Now do you recognize that all we have to do then is, now we can get rid of our brackets since we don't need them, is here it is, the x minus 3y. And then we know this part in factoring by grouping, the x plus 2 goes inside the other parentheses. So the key here in this problem was to recognize that we have to first of all look for the greatest common factor. Think about how many terms there are to help you recognize which kind of factoring to use. If there are 2 terms, look for the difference of perfect squares. If it's a trinomial, either use trial and error, grouping, or look for those special cases. And finally, if there are 4 terms, then just factor by grouping.